Hello, I'm Nicholas Soto, and I'm going to be presenting a hopefully short video on computer hardware and the basics of C++. To begin, we have the CPU, which is short for the Central Processing Unit. Essentially, the CPU is the main part of the computer, which does the essential calculations for the computer. It's what in your video games is what calculates all the big numbers, and it does most of the hard work for the computer. It works by using the cores that are implemented inside the CPU, which essentially do tasks. Um, CPUs can have different number of cores, 2, 4, 16, 128, as many as you can imagine. Of course, there's a limit, but as technology gets better, the amount of cores improves. Um, Next, we have RAM, which is short for random access memory. Now, RAM is different from like hard drives and SSDs because although it does store memory, it's short-term memory. It is essentially data that your computer stores to be thrown out when you turn off your computer. It's things like the tabs on your computers, the amount of programs you have open, the amount of mods you have in a video game. Um, that's what RAM is for. The more RAM you have, the better your computer can handle more tasks at once. The standard for most people is around 16 to 32 gigabytes of RAM. Any more than that, then you're probably somebody that works with things like Photoshop or different like programs for work, like spreadsheets, 3D models and things like that. RAM is very useful for that stuff. Hard drives. It's an older piece of tech. It's used for storing data long term. It's a bit outdated, being replaced by like M.2 processors and SSDs. They work in a similar fashion to that of vinyls and CDs, but of course it's recorded differently. Um, rather than using lasers or like a needle to etch the data inside, it's used by using magnets. Hard drives are very prone to losing data permanently, so they're kind of risky to use. And honestly, I don't know why anybody nowadays would use them, but they're out there, and they did their job while they were good. Now, as for the C++, we begin with comments. Comments are a useful tool for programmers um, to essentially use it as like a messenger for future programmers or the future versions of themselves when they're going back and reading back on their code. It can be used to explain code, simple note taking for later, clarification, things like that. There are essentially two different ways to write notes. You have the double forward slash, which is used for single lines of code, and then you have the asterisk forward slash, which is used for multi-line of multi-code comments. The basically this is used for clarification, really, for the programmer. If used incorrectly, however, it can mess with the white space, which in itself isn't a bad thing, but it can make reading the code a lot harder. So I guess there's a form of etiquette towards it. But yeah, that's that for comments. Now we have variables. Variables are basically data that is inputted through the code or data that's already set in the code. They're used to like compute data. They're used for storing data. Like for example, in the example here, you have an integer that is named age, a variable that is called age, and is set as an integer, and the value for age is set as 20. That basically what that means is that you have a variable with the value of 20, and that variable is an integer. There are many different types of data. Like on the left, I have written down as integer. You have doubles, characters, strings, and then you have floats. There's a lot of different types of variables. These different variables, however, use data, and for proper use of variables, you cannot, like for example, you cannot use integers and then have an integer be set as like 1.5 because integers are meant for whole numbers. If you want to use 1.5, then you have to use like double or float point variables. And these different data sets use different memory, and improper use of data and initialization can really mess with the programming, sometimes causing like logic errors or causing the program to run slow. So, to use variables correctly, it's very important. Now, the difference between integers and floats, I kind of said it earlier, but integers are is a data type used for whole numbers. So numbers like 1, 5, 10, 100, 1,000, whole numbers, no decimals. But floats are used for decimals, like 1.5, 32.7, 3006.5. They're used in a similar fashion. It's really just up to the programmers to which one they prefer to use. Or sometimes it's just convenience. Why would you use float if all the numbers you're going to be using is just whole numbers? Um, However, there is a reason to use float numbers if you need to do it. Like for example, if you're doing integer division and you have, let's say, 7 divided by 2, the program's gonna crap itself. It's not really gonna give you an output. But if you use float and you do 7 divided by 2, it's gonna give you a number with a decimal. Now, float, of course, if you get a number that's way, way too big, not literally in terms of size, but in terms of just how many characters are in a value, the program could also crap itself again. And on the right, it shows you different types of float. Like for example, double is the same thing as float, just more data being utilized to store more characters in a set value. Long can also be used to even increase that further. Now we have if-else statements. If-else statements are pretty simple. It's essentially like, if this is true, then this will happen, and everything else, like if in any other instance where that is not true, this will happen. I have an example here saying, not in coding language, but if I have $25, then I will buy ice cream and a bag of chips. In any other instance that I don't have $25, I will not buy anything. That's essentially what is a if else statement. It can go a little bit deeper than that, but in the most basic terms, that's just what it is. You could also use if statements without an else. Like for example, if I have it in a code as, if I have $25 and I will buy ice cream and a bag of chips, then that piece of code will execute if I have $25. But if I don't, then that line will just be ignored and then moved on to the next. There doesn't have to be an else. You could also have multiple if statements. Like for example, let's say if I have a wallet, and if I do have a wallet that's marked as true, then if I have money inside that wallet, if that's true, it goes on to the next one. If I have $25, and if that's true, then I will buy ice cream. But of course, if the first one fails, then all else is just ignored. Now, here's a simple little example of how if-else statements works. What I have here is money wallet declared as a variable for float, because I use float because you can have cents, like $25.03 or $13.50. And now I have a character out statement essentially asking the user, how much money do you have? And then I have a character in statement where essentially the user inputs the amount of money that they have. That's just what it's asking. Like, how much money do you have? Then you enter the amount of money you have. Then you end the line. And then here we have the if statement. If the money in your wallet is greater than or equal to $25.00, then hooray, you have $25. So buy some ice cream and chips and line. However, if the user inputs, let's say $15, $10 under the minimum, then you will reach the else statement where where it outputs, you're broke, get a job, you can't afford that. And yeah, that's the end of my presentation. Thank you.